Imagine plugging something into a regular wall socket and instantly getting stable 12-volt power powerful enough to run heavy DIY systems, charge large batteries, or power off-grid electronics. Now imagine that device delivering up to 30 amps of current, quietly, efficiently, and compact enough for a workshop bench. That's exactly why thousands of DIY enthusiasts and tech observers have started talking about one name again: Maxwell Chikumbutso. Because the device gaining attention right now isn't a massive industrial power unit. It's something far more interesting. A 220-volt to 12-volt 30-amp charger, designed to turn ordinary household electricity into powerful low-voltage energy that can run everything from battery banks to custom electric systems. At first glance, that might not sound revolutionary. After all, power converters already exist. But the buzz around this particular charger isn't just about the voltage conversion. It's about how it could change the way DIY builders think about power entirely. Across maker forums, engineering channels, and independent tech communities, people are beginning to see the possibilities. A compact device that converts standard 220V AC power into high-current 12V DC output instantly opens doors to countless projects. Electric vehicle prototypes, solar storage systems, portable power stations, custom robotics labs, high-capacity battery charging setups. For DIY builders, 12-volt power is the universal language of experimentation. Cars use it. Boats rely on it. Solar batteries store it. Most electronic systems start with it. But generating large, stable 12-volt current safely has always required either bulky equipment or complex setups. That's where a 30-amp charger changes the equation. 30 amps at 12 volts means roughly 360 watts of usable power output. That's not just enough to trickle charge small batteries. That's enough to run high-power LED lighting systems, charge deep-cycle batteries, operate off-grid control electronics, power custom automotive modifications, and even support small experimental EV systems. For a DIY enthusiast, that kind of accessible power becomes a creative tool. Imagine a garage workshop where someone is building their own electric scooter. Instead of relying on slow battery chargers or improvised adapters, they connect a high-current 12V charger that fills battery packs quickly and safely. Now imagine another builder designing a portable camping power system. A simple 220-volt input connected to a charger like this could rapidly refill a large battery bank used for lighting, refrigeration, or mobile electronics. Even robotics engineers benefit from stable low-voltage power. Robotic motors, controllers, and sensors often operate on 12-volt systems, and inconsistent voltage can destroy delicate electronics. A reliable charger that delivers stable DC output becomes more than just a charger. It becomes the backbone of an entire DIY power ecosystem. But the conversation surrounding this device goes deeper than technical specifications, because the inventor behind it has become one of the most debated figures in emerging technology. Some supporters describe Maxwell Chikumbutso as a visionary engineer trying to build solutions for Africa's technological independence. Others remain skeptical, questioning the bold claims often associated with his inventions. Regardless of the debate, one thing is undeniable. His projects consistently capture attention because they aim to simplify complex technologies into accessible tools. Instead of billion-dollar laboratories, many of his concepts revolve around devices that could be used in small workshops, startups, and local innovation hubs. And that's exactly where something like a 220V to 12V high-current charger fits perfectly. In many developing regions, advanced industrial power equipment isn't easily accessible, but 220-volt wall power is common. Transforming that into reliable DC power for engineering projects could allow small inventors to experiment with electric vehicles, renewable energy storage, or automation without needing expensive imported equipment. Suddenly, a simple charger becomes part of a much bigger idea. An ecosystem where individuals build solutions locally, where students assemble energy systems in small labs, where makers test prototypes without waiting for large corporate infrastructure. And that's the kind of environment where technological revolutions quietly begin. Because many world-changing technologies didn't start in massive research centers. They started in garages, workshops, tiny experimental labs. In fact, some of today's most powerful technology companies began with individuals experimenting with electrical circuits in small spaces. The difference between an idea and a breakthrough often comes down to having the right tools available. And power, stable, reliable power, is always the first requirement. Without it, experiments stop before they even begin. With it, ideas can grow into prototypes. Prototypes can become inventions. And inventions can eventually reshape industries. That's why DIY builders pay attention to tools that seem simple but unlock huge possibilities. A device capable of delivering consistent 12-volt high-current power might not make headlines like electric cars or artificial intelligence, but it quietly enables the people building those technologies in the background. Because behind every new electric machine, every experimental robot, every custom energy system, there is always a power source somewhere. And when that power becomes easier to access, innovation spreads faster. In garages, in community labs, in student engineering clubs, in small technology startups trying to build the next breakthrough. And once those environments gain the ability to experiment freely with reliable power systems, something interesting begins to happen. Ideas multiply, projects evolve faster, and suddenly, a tool originally designed as a charger starts becoming something much more important. It becomes the foundation for entirely new DIY power architectures. Builders begin connecting multiple battery banks, designing portable energy stations, testing hybrid power systems that combine solar panels, storage batteries, and fast charging circuits. And as these projects grow more ambitious, the need for efficient power conversion devices becomes even more critical, because every experimental system eventually faces the same challenge. How do you move electricity from one form to another efficiently, safely, and without wasting energy? That question has shaped the entire history of electrical engineering. And it's exactly the kind of challenge that continues driving innovators like Maxwell Chikumbutso to design new tools. Tools that might look small today, but could quietly become essential pieces in the workshops where tomorrow's technologies are being built right now. And as more engineers, hobbyists, and experimenters start testing devices like this charger in real-world projects, something fascinating begins to happen. People stop seeing it as just a power converter. They start seeing it as a gateway to building systems they previously thought were too complicated to attempt. And that's where the story becomes even more interesting, because once accessible power tools enter the hands of creative builders, the next wave of innovation rarely comes from large corporations. And that's where things begin to take a fascinating turn. Because once reliable power tools enter the hands of curious builders, experimentation accelerates in ways most people never notice at first. A charger like this doesn't just sit on a workbench. It becomes part of a growing network of projects. Someone connects it to a large deep-cycle battery. Another builder uses it to stabilize power for a custom lighting system. A student engineer plugs it into a prototype robot that needs steady 12-volt current to drive motors and sensors. Little by little, the same tool begins appearing across completely different types of innovation. Automotive modification garages start using it to test electrical systems outside of vehicles. Solar hobbyists begin pairing it with battery banks to simulate charging cycles. Electronics tinkerers integrate it into test benches where they experiment with circuit boards, controllers, and power modules. The more people explore its capabilities, the more possibilities appear. Because the real power of a 30-amp charger isn't just the current it delivers. It's the stability it provides during experimentation. One of the biggest challenges DIY builders face is inconsistent power. Voltage spikes can damage circuits. Weak chargers take hours to refill batteries. And unstable current can cause motors, controllers, or sensors to behave unpredictably. When power becomes stable, something important happens. Projects stop failing for simple reasons. Builders can focus on designing better systems instead of troubleshooting weak power sources. And that's where the conversation around devices like this begins expanding beyond the charger itself. Because people start asking a bigger question. If reliable, high-current DC power becomes widely available in small workshops, what else becomes possible? For instance, think about the rapid growth of electric mobility. Electric bikes, electric scooters, DIY electric go-karts. These projects often rely on battery packs built from lithium cells or lead-acid batteries. Charging and testing those battery systems safely requires dependable DC power. Without proper charging equipment, experimentation slows down. But with tools capable of delivering strong, controlled 12-volt output, builders gain the ability to test systems repeatedly without waiting hours between cycles. That speed alone can dramatically accelerate development. One weekend project suddenly becomes 10 iterations. 10 iterations become a refined prototype. And prototypes eventually evolve into real products. This is exactly how many grassroots technologies begin spreading. Not through massive funding, but through accessible tools that allow people to build faster. There's another dimension to this story as well: energy independence. In many regions of the world, people rely heavily on centralized power infrastructure. But small-scale innovators have been quietly exploring ways to create local energy solutions. Battery storage systems, backup power units, mobile energy stations for remote areas. These systems all require reliable power conversion equipment. And a device that converts 220 volts from a wall outlet into strong 12-volt DC output becomes a fundamental building block. It allows batteries to be charged quickly. It allows systems to be tested safely. And it allows builders to experiment with energy storage technologies without investing in expensive industrial hardware. This is especially important for communities where access to advanced engineering equipment is limited. In those environments, a single versatile power device can support dozens of experiments. Students learn faster. Inventors prototype more ideas. And small innovation ecosystems begin forming around shared tools. That's often how technological momentum begins. Not with one breakthrough invention, but with many people having the ability to experiment at the same time. And the moment experimentation spreads widely, creativity multiplies. Someone modifies the charger to integrate smart monitoring. Another builder pairs it with solar controllers to create hybrid charging systems. A third group designs portable battery packs that recharge quickly using high-current DC input. Each idea builds on the previous one. Soon, what started as a simple charger becomes part of a growing ecosystem of energy experimentation. And this is something that has happened repeatedly throughout technological history. Early personal computers started as hobbyist kits. Early drones were built by enthusiasts modifying radio-controlled aircraft. Early electric vehicle prototypes were assembled in small workshops long before corporations entered the industry. In every case, the same pattern appeared. Accessible tools allowed builders to experiment. Experiments produced prototypes. Prototypes evolved into innovations. And those innovations eventually reached the global market. That's why DIY communities often pay close attention to devices that simplify complex electrical tasks. A charger that reliably converts high-voltage AC into strong DC output might seem like a small invention. But for builders, it removes one of the biggest barriers in electrical experimentation: the barrier of power availability. Because without power, even the most brilliant engineering idea remains just a sketch on paper. With power, it becomes a working prototype. And when prototypes begin appearing everywhere, something remarkable happens. Inventors start pushing boundaries. Someone attempts a larger battery system. Another builder designs a portable off-grid power unit. A robotics team experiments with new motor configurations that require steady current supply. Each new attempt expands what DIY engineering communities believe is possible. And once that belief changes, the pace of innovation begins accelerating. Because builders are no longer asking, "Can we power this?" They're asking something far more exciting. What else can we build now that we have the power to try? And this is the moment when simple tools often transform into something far more influential than their creators originally imagined. Because once thousands of creative minds begin experimenting with a reliable energy platform, the next wave of inventions can emerge from anywhere. A student lab, a small garage workshop, a rural innovation hub, or a group of engineers working late into the night trying to solve problems others assumed were too complicated to attempt. And as more builders continue exploring the possibilities of devices like this 220-volt to 12-volt 30-amp charger, New ideas keep appearing. Some small, some ambitious, some experimental. And when that kind of experimentation begins spreading across different communities, something subtle but powerful starts to happen. Knowledge begins moving faster than ever. A builder somewhere tests a new battery setup and shares the results online. Another engineer in a different country watches the demonstration and adapts the idea for a completely different project. Soon, dozens of variations appear, each one pushing the original concept further. This is how modern DIY innovation works. It's not one inventor working alone. It's a network of curious minds, constantly building, modifying, and improving the same ideas. And in that environment, tools that simplify power management become incredibly valuable. Because almost every experimental machine, no matter how complex, relies on the same basic foundation: electricity. Stable electricity. When that foundation becomes easier to control, entire categories of projects suddenly feel more achievable. Take electric mobility as an example again. Many hobbyists dream of building their own electric vehicles. Not just scooters or bikes, but experimental transport systems, small electric carts, utility vehicles, or personal mobility prototypes. But building the vehicle itself is only part of the challenge. Testing and charging the battery system safely is often the biggest technical hurdle. A reliable 12-volt high-current charger can become a testing bridge between concept and reality. It allows builders to run electrical diagnostics, to safely charge battery modules, to simulate real operating conditions inside a workshop before taking a prototype into the real world. That testing process can make the difference between an idea that stays theoretical and one that becomes functional. And once builders gain confidence in their power systems, they start exploring bigger possibilities. Energy storage is one of those frontiers. Around the world, more people are experimenting with home battery systems. Some want backup power for outages. Others want to store solar energy during the day and use it at night. But battery systems require careful charging and management. Too little power, and charging becomes painfully slow. Too much unstable current, and the batteries could be damaged. Devices capable of delivering controlled, consistent DC output become essential tools for building these systems. And when people realize they can assemble reliable energy storage solutions with accessible equipment, creativity expands again. Suddenly, someone designs a portable battery pack for outdoor expeditions. Another builder creates a mobile charging station for electric bikes. A third group experiments with hybrid energy systems that combine grid power, batteries, and renewable sources. Every new project pushes the boundaries just a little further. And all of it starts with something deceptively simple: power conversion. Turning electricity from one form into another. From high-voltage AC into usable DC. From the wall socket into the energy systems that power modern machines. That process sits quietly at the center of almost every piece of technology we use today. Yet it's often overlooked. People talk about electric vehicles, artificial intelligence, robotics, and smart devices. But behind each of those innovations lies a network of power systems converting electricity into the exact form those machines require. That's why tools that improve power accessibility can have ripple effects far beyond their original purpose. Because when engineers, students, and hobbyists gain easier access to reliable power conversion, experimentation spreads into entirely new areas. Robotics labs begin testing stronger motors. Automation enthusiasts design small industrial machines for workshops. Drone builders experiment with new battery technologies. And the more these experiments succeed, the more confidence builders gain to try even bigger projects. It's a cycle that feeds itself. Accessible tools lead to more experimentation. More experimentation leads to new discoveries. New discoveries inspire even more builders to join the movement. And slowly, a quiet technological ecosystem begins forming, not in massive corporate laboratories, but in places where curiosity and creativity meet practical tools. Small engineering classrooms, community maker spaces, home workshops filled with wires, circuit boards, and half-assembled prototypes. In those environments, every reliable tool becomes part of the innovation process. A power converter here, a battery system there. A controller board wired to a custom machine. Individually, each piece may seem ordinary, but together, they create the infrastructure that allows grassroots innovation to flourish. And this is where the conversation surrounding the inventions of Maxwell Chikumbutso becomes particularly interesting, because many of his projects revolve around the same core idea: making advanced technologies more accessible to everyday builders and emerging innovators. Whether people agree with every claim surrounding his inventions or not, the broader concept behind accessible technology continues gaining attention. The idea that powerful engineering tools shouldn't be limited to massive corporations or well-funded laboratories. Instead, they should be available to the students, hobbyists, and independent engineers who often drive unexpected breakthroughs. History has shown that when those innovators gain access to the right tools, extraordinary things can happen. Entire industries can emerge from small experimental communities. Technologies that once seemed impossible can suddenly become practical. And sometimes, the smallest components quietly enable the biggest transformations. A converter, a charger, a control board, a battery system. These are the building blocks behind modern technological revolutions. Not glamorous on their own, but essential for everything that comes after. And as more people continue exploring the possibilities of compact, high-current chargers like this one, a new wave of experimentation keeps unfolding. Some builders will use them simply to power projects. Others will modify them, integrate them into larger systems, or design entirely new energy platforms around them. Ideas will collide. Designs will evolve. And somewhere in a workshop, someone might take a simple power conversion tool and use it as the starting point for something far more ambitious than anyone expected. Because the most exciting part of technological progress isn't always the finished invention. It's the moment when the tools become accessible enough that anyone with curiosity can begin building. And once that moment arrives, innovation stops being limited to a few laboratories. It spreads everywhere. Across garages, across classrooms, across small startups and ambitious young engineers determined to turn experiments into real-world solutions. And as those quiet experiments continue spreading across workshops, labs, and garages, something important begins to reveal itself. The real story was never just about a charger. It was about possibility. Because when builders gain access to reliable power tools, they gain the freedom to test ideas that once felt out of reach. A student can prototype an electric vehicle controller. A hobbyist can assemble a portable energy station. An engineer can design smarter battery systems right from a small workspace. All of it begins with something simple: the ability to convert and control electricity. That's what makes devices like the 220-volt to 12-volt 30-amp charger so interesting to the DIY world. It takes a powerful source of energy from an ordinary wall outlet and transforms it into something builders can actually use to create, test, and innovate. And while it may look like a small piece of hardware sitting quietly on a workbench, the impact it can have inside a creative workshop is far greater than most people realize. Because behind every prototype, behind every custom-built machine, behind every experimental electric system, there is always a moment where someone needed stable power to bring an idea to life. That moment is where innovation begins. For the growing community of DIY engineers and tech enthusiasts, tools that simplify power conversion remove one of the biggest obstacles standing between imagination and reality. And that's why inventions connected to Maxwell Chikumbutso continue attracting curiosity. Not just because of the technology itself, but because they spark conversations about who gets to build the future. Will innovation remain concentrated in large corporations and elite laboratories? Or will accessible tools allow thousands of independent builders to experiment, prototype, and develop the next generation of technology from their own workshops? History suggests the answer may already be unfolding. Many of the world's most influential inventions began in places that looked surprisingly ordinary. A garage filled with circuit boards. A small lab run by passionate students. A workshop where someone refused to stop experimenting. The tools were simple, but the ideas were powerful. And when the right tools reached the right hands, entire industries were born. So while a 220-volt to 12-volt charger may not sound like the kind of device that changes the world, it represents something deeper within the maker community. It represents access. Access to power. Access to experimentation. Access to innovation. Because when electricity becomes easier to control, builders stop asking whether something can be powered and start asking what incredible thing they should build next. And somewhere out there right now, a curious engineer might already be plugging in a device like this, connecting wires to a battery system, watching the voltage stabilize, and realizing that a project they once thought impossible is suddenly within reach. That moment, when an idea becomes buildable, is where every technological revolution truly begins. And as more creators continue experimenting with tools like this, the next wave of DIY innovation may already be taking shape in places most people would never expect. Small workshops, student labs, garage engineering spaces,